Canada's rivers have been struggling for decades with declining salmon populations that once filled waterways from coast to coast. Industrial development, pollution, and climate change have pushed many salmon species to the brink of collapse, leaving entire ecosystems hanging by a thread. But Canadian scientists decided to take a massive gamble that shocked the environmental world. They developed what they called super salmon, genetically enhanced fish designed to survive in conditions that would kill regular salmon populations. These weren't your typical fish from the local stream. The super salmon were engineered to resist diseases that had been wiping out natural populations, grow faster in warming waters, and navigate through polluted river systems that regular salmon couldn't handle. The project started when researchers realized traditional conservation methods weren't working fast enough. Salmon numbers were dropping so quickly that entire river ecosystems faced complete collapse within just a few seasons. Scientists spent years developing these enhanced fish in controlled laboratory environments. They carefully modified genetic markers to boost immunity, disease resistance, and temperature tolerance without creating something that would harm existing ecosystems. The enhancement process focused on three key areas that regular salmon struggled with in modern river conditions. First, they boosted the fish's immune system to fight off parasites and diseases that had become more aggressive due to warming waters. Second, they improved the salmon's ability to process oxygen in polluted water conditions. Many rivers had oxygen levels that were too low for regular salmon to survive, but the super salmon could thrive even in these degraded environments. Third, they enhanced navigation abilities so the fish could find spawning grounds even when traditional routes were blocked by development. These super salmon had improved sensory systems that helped them adapt to changes in river flow and structure. The genetic modifications weren't random experiments, but targeted improvements based on decades of studying why salmon populations were failing. Scientists identified specific weaknesses in regular salmon DNA and strengthened those exact areas. Environmental groups initially opposed the project, calling it dangerous genetic manipulation that could backfire. They worried these modified fish might outcompete natural species or create unexpected ecological problems. But the salmon crisis had reached such extreme levels that doing nothing meant watching entire river systems die. Canadian wildlife officials faced a choice between trying something revolutionary or accepting the complete collapse of salmon populations. The super salmon looked almost identical to regular salmon, but laboratory tests showed they performed dramatically better under stress conditions. They survived in water temperatures that killed normal salmon, fought off diseases that devastated wild populations, and grew to full size much faster. After years of testing in controlled environments, scientists felt confident these enhanced fish could restore river ecosystems. The super salmon showed no aggressive behavior toward other species and seemed to fill the exact ecological role that regular salmon once played. The decision to release millions of these fish into Canadian rivers sparked heated debates across North America. Some praised it as innovative conservation, while others called it reckless genetic experimentation on a massive scale. Wildlife officials knew they were taking an enormous risk, but traditional conservation had failed. Rivers that once supported hundreds of thousands of salmon now had populations in the low thousands or were empty. The release program targeted rivers across multiple provinces, focusing on waterways where salmon populations had disappeared entirely. Scientists wanted to see if super salmon could not only survive but also restore the ecological balance that had been lost. Each release was carefully monitored with tracking devices and regular population surveys. Scientists needed to know immediately if something went wrong or if the super salmon were causing unexpected problems. The initial releases included millions of juvenile super salmon distributed across dozens of river systems. This wasn't a small pilot program, but a full-scale attempt to rebuild Canada's salmon populations using enhanced genetics. Environmental monitoring stations were set up throughout the release areas to track water quality, fish populations, and overall ecosystem health. Scientists wanted comprehensive data on how these modified fish affected their new environments. The stakes couldn't have been higher because failure would mean losing these river ecosystems forever. But success could revolutionize how we approach conservation and species recovery in an era of rapid environmental change. The first super salmon releases happened during peak spawning season when conditions were optimal for fish survival and adaptation. Scientists chose locations where regular salmon had disappeared entirely, leaving empty ecological niches that needed to be filled. Initial reactions from local communities ranged from excitement to serious concern about unleashing genetically modified organisms into wild environments. Fishing communities that had watched their traditional livelihoods disappear were desperate enough to support almost any solution. Within the first few months, monitoring stations detected super salmon in rivers where no salmon had been seen for over a decade. These fish weren't just surviving, they were actively exploring territories and establishing the behavioral patterns that healthy salmon populations typically display. The enhanced immune systems proved effective immediately, as the super salmon showed resistance to parasites that had killed previous reintroduction attempts. Regular salmon releases in recent years had failed within weeks due to disease outbreaks, but the modified fish remained healthy. Water temperature monitoring revealed the super salmon were thriving in conditions that would have stressed regular salmon beyond survival limits. Rivers that had become too warm for natural salmon populations now supported growing numbers of these enhanced fish. Environmental groups continued to express concerns about the potential long-term consequences of releasing millions of genetically modified fish. They worried about unknown effects on other species, genetic pollution of wild salmon populations, and the precedent of using genetic engineering for large-scale environmental interventions. But early data showed the super salmon were behaving exactly like regular salmon in terms of feeding patterns, migration routes, and spawning behaviors. They integrated seamlessly into existing river ecosystems without disrupting other wildlife. The enhanced navigation abilities became obvious as super salmon successfully found spawning grounds in rivers that had been altered by decades of human development. These fish adapted to changed water flows, new obstacles, and modified riverbank conditions that had confused previous reintroduction attempts. Predator fish species that had been struggling due to a lack of salmon prey began showing signs of population recovery. Bears that depend on salmon runs started returning to rivers where they hadn't been seen in years. The super salmon's faster growth rates meant they reached breeding age sooner than regular salmon would have. This accelerated timeline could speed up population recovery, but also raise questions about long-term genetic stability. Fish ladders and other salmon infrastructure that had been unused for years suddenly had traffic again. Super salmon were using the same migration routes that wild salmon had used historically, proving their behavioral programming remained intact. Commercial fishing operations in coastal areas began detecting super salmon mixed in with other fish species. The modified salmon appeared to be completing full life cycles from river birth to ocean growth and back to river spawning. Scientists tracking individual fish through implanted monitoring devices found that super salmon were establishing territorial behaviors similar to wild salmon. They weren't acting like invasive species, but rather like native fish reclaiming their historical habitat. The enhanced disease resistance proved crucial as several rivers experienced pathogen outbreaks that would have devastated regular salmon. Super salmon populations continued growing even when other fish species showed signs of illness. Water quality measurements in rivers with successful salmon populations began showing improvements. The presence of large fish populations indicated that overall ecosystem health was starting to recover from decades of decline. Local indigenous communities that had traditional connections to salmon fishing reported mixed feelings about the genetic modifications. While they appreciated seeing salmon return to their rivers, they questioned whether artificially enhanced fish could truly replace the natural populations their ancestors had known. Tourism related to salmon watching and fishing began increasing in areas where super salmon populations were establishing. Communities that had lost salmon-based tourism income started seeing economic benefits from the restoration efforts. The super salmon was filling ecological roles beyond just providing food for predators. Their spawning activities were bringing marine nutrients inland, and their presence was affecting river chemistry in ways that benefited other species. Scientific teams monitoring the releases reported that super salmon were exceeding expectations in terms of survival rates, population growth, and ecosystem integration. The initial results suggested the genetic enhancements were working exactly as designed. However, scientists remained cautious about declaring early success, knowing that long-term environmental impacts might not become apparent for several years. The actual test would come when these super salmon attempted to reproduce and establish self-sustaining populations. After one full year, the results from Canada's super salmon experiment exceeded even the most optimistic scientific projections. Rivers that had been biologically dead were showing signs of life not seen since before industrial development changed the landscape forever. Population surveys revealed that super salmon numbers had grown exponentially, with successful reproduction cycles producing healthy offspring. The genetic modifications appeared stable across generations, meaning the enhanced traits were being passed down reliably. Most surprisingly, the presence of super salmon triggered a cascade effect that restored entire river ecosystems. Other fish species began returning to rivers where they had disappeared, and aquatic plant life started recovering from decades of decline. The enhanced salmon's ability to thrive in polluted conditions helped clean the rivers themselves. Their increased activity and successful spawning runs brought marine nutrients inland, while their presence indicated that water quality was improving overall. Bears, including grizzly and black bears, began establishing regular feeding patterns around the super salmon runs for the first time in generations. Wildlife cameras captured footage of bears fishing in rivers where salmon hadn't existed for over 20 years. Indigenous communities reported that traditional fishing practices were becoming possible again as super salmon populations reached levels that could support sustainable harvesting. Elders who hadn't seen healthy salmon runs in their lifetimes were able to teach younger generations traditional fishing techniques. The economic impact extended far beyond just fishing, as salmon-related tourism brought millions of dollars into rural communities. Hotels, restaurants, and guide services that had struggled for years suddenly had customers eager to see the restored salmon populations. Scientists studying the genetic stability of super salmon found no evidence of harmful mutations or unexpected genetic drift. The modified fish appeared to be breeding true to their enhanced characteristics while maintaining all the ecological behaviors of wild salmon. Water quality monitoring revealed significant improvements in rivers with established super salmon populations. Oxygen levels increased, bacterial contamination decreased, and overall river health metrics showed dramatic positive changes. The success triggered international interest as other countries began considering similar genetic enhancement programs for their own declining fish populations. Australia, New Zealand, and several Scandinavian nations sent scientific delegations to study Canada's super salmon project. Environmental groups that initially opposed the releases began acknowledging the positive results while maintaining concerns about long-term consequences. Some activists shifted their position to cautious support, while others continued pushing for more traditional conservation approaches. The super salmon's enhanced navigation abilities proved especially valuable as climate change continued altering river conditions. These fish successfully adapted to changing water temperatures, flow patterns, and seasonal variations that would have challenged regular salmon. Commercial fishing operations reported that super salmon were indistinguishable from wild salmon in terms of taste, texture, and nutritional content. Consumer acceptance was high, and market demand for sustainably restored salmon populations skyrocketed. The genetic modifications showed no signs of spreading to other fish species, addressing one of the primary concerns about releasing modified organisms. Super salmon remained reproductively isolated while still fulfilling their ecological role. Scientists began planning expanded releases into additional river systems based on the overwhelming success of the initial program. They identified dozens of rivers that could support super salmon populations and begin their own ecosystem recovery processes. The project demonstrated that carefully designed genetic enhancements could be a powerful tool for conservation and species recovery. Rather than replacing traditional conservation methods, the super salmon approach offered a new option for extreme situations. Long-term monitoring systems established during the first year would continue tracking super salmon populations for decades to ensure continued success. Scientists wanted comprehensive data on genetic stability, population dynamics, and ecosystem impacts. The restoration of salmon populations had cultural significance beyond just environmental benefits as indigenous communities reconnected with traditional practices. Salmon ceremonies and cultural events that had been suspended for decades began retaking place. 1 year after the initial releases, Canada's super salmon experiment had transformed from controversial genetic engineering into a conservation success story. The results proved that innovative approaches could restore ecosystems that seemed beyond traditional recovery methods. If this incredible conservation breakthrough has you excited about the future of our rivers and wildlife, make sure to hit that like button and subscribe for more amazing stories about environmental restoration projects that are changing the world around us.